Okay, if you remember yesterday, you were given a half sheet of paper to write this problem on and solve it. So right now we're doing that, and then I'll collect it, and then I'll go over it in just a few minutes. Okay, so everybody has had an opportunity to do this problem, and now we'll kind of look at what the solution is. Um, so just a reminder, getting one side equal to 0. Then over on the right there, I factored that. So our solutions are -5/2 and 1. Our intervals from -infinity, and maybe I will write on here. Um, our intervals from -infinity to -5/2, -5/2 to 1, 1 to infinity, and so then there's my intervals on there. Um, I try something in each interval, figure out if things are positive or negative. Since this is just less than 0, the interval at which it is less than 0 is from -5/2 to -1, and so there's our solution. The parentheses as the endpoints, and then the solution written is just right there as well. How many people got it right? Okay, well, good. So now we also want to look at unusual situations, and maybe I'll use this there. Think about unusual situations, the fact that this parabola could be completely above the x-axis, and in that case it's always positive, right? So if I'm looking at when this parabola is greater than 0, it would be always or all real numbers. If I'm looking at when it would be less than zeros, it would be the empty set, and possibly it's gonna hit right there one time, and so then there's either one value or all values except one value. So those are kind of our unusual solutions, and I have 4 problems with unusual solutions. So generally, we're really not graphing the parabola, but in the back of our minds, we want to know what that parabola looks like. And so you'll notice these are very related problems. So 4A and B are the same quadratic, but one is greater than 0, one's less than 0, and then C and D are the same quadratic and just a little different situations as well. So for this first one, does this first thing we want to kind of think about, 0 is on one side, does this factor? Is there something that multiplies to be 4 and adds to be 2? 2 and 2 doesn't add to be 2 though. So does that factor? No, it doesn't factor. And so our next job, we just want to find the zeros, is to use the quadratic formula. So x equals -b, so -2 plus or minus the square root of -2, or 2 squared, excuse me, which is 4, minus 4 times a, which is 1, times c, which is 4. Got my big dot there again, all over 2 times 1. And so x equals -2 plus or minus the square root of, well, it looks like 4 minus 16, right? And so that's -12 over 2. What's the problem with that? What's the problem? Right, so is there a real solution here? No. And so that means this parabola doesn't hit the x-axis at all. And then we can use that fact, the leading coefficient, and the fact that it kind of use up. So in our minds, we should know or have an idea of what's happening there. So since it does not cross the x-axis and the leading coefficient is 1 and it's x squared, we know that it's going to be some kind of a parabola. We don't know where that parabola is going to be along here, and we don't care, because all we care about is the fact that there is no real 0, and that it's going to be above that all the time. So when is this going to be greater than 0? Well, it's always going to be greater than 0. So if this is my number line, I'll maybe put a couple numbers on there, -1, 0, and 1. So my solution is written in written form from negative infinity to infinity, and my graph of that is just graphing the entire number line. So I tried to make it look like two different colors so you could see that that's what I'm doing. So all real numbers is the solution for that one. This next one is the same quadratic, so we already know there's no real solutions. We also know what that parabola looks like. It's somehow above there. So when is this quadratic x squared plus 2x plus 4 less than 0? When is it less than 0? Never. So it is never less than 0. I'll just put a number line, -1, 0, and 1. So the number line is just blank. And our solution set is can be given one of two ways. Do you remember how to give the empty set as a solution? Either brackets with nothing in them or empty set 0 with a slash through it. Not the empty set inside of the brackets, right? Because then there would be something in there, that symbol. So that's a couple of unique solutions as we look at that one. And then our next one is, again, you know, the two quadratics are going to be the same. And so now let's look at 4C, and maybe I'll just slide that up a little bit. Does this one factor? X squared is x and x. What multiplies to be 1 and adds to be 2? 1 and 1. So plus 1, or x plus 1 in parentheses squared. Either way, x is equal to -1 multiplicity 2. So what does that mean about our parabola as we look at it? It's just touching down on there. And, you know, we know from the leading coefficient. But since we do have a since we do have a 0 here, we can do an interval table. And so on my number line in a little bit here, I'm going to have -1 there. And, well, I'll maybe put -2 and 0 on there as well. And my interval table, is going to go from -infinity to -1, and then from -1 to infinity. And I can just pick a super negative x, like -100. If this is -100 plus 1 is a big negative number times a negative times a negative is a positive. And if it's a big number like 100 plus 1, and 100 plus 1, positive times a positive is also a positive. So in both intervals, it is positive. So in this case, I'm looking at when this is less than or equal to 0. So what is my solution? Right, what if it's at -1? I'll just throw that back as a question. What if it's at -1? Would -1 work? Right. So in this one, and so we always kind of have to look at that kind of carefully. So in this one, we're asked when is this x squared plus 2x plus 1 less than or equal to 0? So it can be equal to 0. So we can have that, that -1. So our solution, that's all that works. These are all positives, so none of those work, my intervals. But I get that single point on there, and my solution when I write it is just the number 1. And I put that in a bracket. Bracket? Brace. Braces. That's braces. Just sorry. That's braces. I put it in braces. My bad. So, okay, if you had to listen to that, sorry. uh, so, um, this is the same problem. So over here we know x equals -1 is that 0. We've already got our interval table here as well, you know, for this same one. So now we're just saying that, here we are. Um, -2, -1, and 0 are our kind of key terms there. So now, what's our solution for this one? X equals -1 is a 0, makes it equal to 0. I want it to be greater than 0. Well, it's greater than 0 in that interval. It's greater than 0 in that interval. So what is it? Yes, in the old days, we would do the open circle, but now we're doing it like with the parentheses. So here's what this one would look like. First, I'll write the solution because both of these intervals work. Do you all agree with that? So the solution in interval notation is -infinity to -1, union -1 to infinity. So there's the solution. And then to put it on here, we're doing this open parenthesis means the open circle. So at -1, it's the parenthesis going left, I guess is the way I'll say that, and then shading everything that way. And then from -1, it also goes from here and shades out that way. So you can see why these four answers are called unique solutions. Well, it's just two conventions or notations that you'll see. And so, yes, as we get to higher math, we tend to just use these symbols and just slap them on the number line versus like when we're a little younger and just learning that and don't do things like interval notation, then we do the open circle and the closed circle and so I have seen at both high school and college levels books that do both. I'll just say it that way. So I don't know that it has to be one way or the other exactly as we look at that. So that gives us our unusual solutions, and this is just from example 1. And the test interval, we've kind of did all that yesterday, I think. So now we want to look at rational inequalities. And I think I commented on this yesterday, but the difference now with rational inequalities is when we were doing the polynomial kind of inequality, we were just looking at the zeros, right? And kind of what happened there and making our intervals. Well, now because it's going to be a fraction, we can also get those denominators equal to 0, but that's where there are asymptotes, right? Or vertical asymptotes. And so those, if it's less than or equal to or greater than or equal to, we can never equal those no matter what. But zeros we can be equal to. So just throws a little extra dynamic in there as we look at it. And so we look at the fact that rational expression can only change its sign at its zeros. So a rational expression can change sign at its zeros and at its undefined values. X values for which the denominator is equal to 0. So we just have a little extra work, and then we also have to just keep in mind sometimes, we forget the zeros can be included. These can kind of never be included, even if it's or equal to as we look at that. So knowing that, we'll just start with a deceptively easy looking problem. And anybody know why I'm saying it's deceptive? It looks easy because it looks kind of linear, but do you notice anything? Is it equal to 0 or is one side equal to 0? No. So actually this is a more challenging problem than, at first glance. At first glance you're like, oh look, I just get the numerator equal to 0 and the denominator, but it's not going to be that nice. So I really have to subtract 3 from both sides, and so then my real problem is 2x minus 7 over x minus 5 minus 3 the whole number, and I'm going to leave a little gap there, is less than or equal to 0. Do you know why I left the gap? I'm going to get a common denominator. Does that make sense? So my fraction is, my denominator that I have is x minus 5. So to not change the value of anything, I'm going to multiply by the fraction x minus 5 over x minus 5. And my 3 is like 3 over 1. And that's going to allow me to get my common denominator. So this one is a little more intense than, at first glance it might have looked like. And so when I do this, I'm going to just get my whole denominator, or numerator, excuse me there, 2x minus 7. And I'm going to distribute that right away. Minus 3x. And then am I right in saying plus 15? And then all over, oh, I see I forgot a parenthesis there. And then all over um, the x minus 5. And this is still less than or equal to 0. Now I'll kind of combine like terms, so I get negative x plus 8 over x minus 5 less than or equal to 0. So now this is actually the problem. So, if this had started out as an easy problem, it would have started like this. Otherwise, we have to get one side set equal to 0, and then kind of look at what's happening. Now, instead of calling these the zeros, I'm going to call them the key points. And maybe we called them key points yesterday, I don't know. But when the numerator is equal to 0, that's a 0, right? Do you agree? When the numerator is equal to 0, that's a 0. So there is a 0 when negative x plus 8 equals 0. So negative x equals negative 8, or x equals 8. So that's a 0. And there's an undefined when the denominator is equal to 0. So x minus 5 equals 0, or x equals 5. So these are our two key points, and I do try to write myself a little note about the 0 or undefined, because this one is, and I'll use the magic pen a second. This one is, oh, less than or equal to 0. So we know that it can include the zeros. And so this 8 will be included, but the 5 will never be included because that's an asymptote. So if that's on a boundary, that can be used here. And again, I'm interested in sign plus or minus signs as I'm looking at this. So I'll start my number line, and to be honest, and I don't think I did this way yesterday, but now I'm going to do my number line where I'm really just going to write my key numbers on there. So 5 is to the left and 8 is there. Oh, but I just did that backwards. I don't know why. 5 is there and 8 is there. And so I'm just putting on the numbers I need. As long as I have them on a number line order, I'm good to go. And then my intervals will be negative infinity to 5, 5 to 8, 8 to infinity as I go. So I'll do my interval table up here. So interval x and the sign of y, And my intervals from negative infinity to 5, 5 to 8, 8 to infinity. So there's my three intervals. From negative infinity to 5, it's easy to choose 0. And if I choose 0, this would be like 8 over negative 5, right? A positive over a negative. So that will be negative. Between 5 and 8, I just picked 6 for mine. And then negative 6 plus 8 is going to be positive. And 6 minus 5 is also going to be positive. So a positive over a positive is positive. 8 over 8 to infinity is my next one. I'll pick something like 10, just easy to figure out. Negative 10 plus 8 is a negative. Negative 10, or excuse me, 10 minus 5 is a positive. So that one is negative. And I'm looking at when this is less than or equal to 0. So less than or equal to 0, that works. Less than or equal to 0, that works. So notice we did this yesterday too. We give these intervals as up to 5 and starting at 8 because then we want to say, okay, over here 8 is a 0. So can we include 8? Yes, 8 can be included in our solution part, but 5 is where it's undefined. So even though um, in this interval, it's negative. At 5, it's undefined. So our solution is from negative infinity to 5. And does it include the 5 or not? No. Union with 8, oh, 8 to infinity, and does it include the 8? Yes. 8 is included because that is a 0 to infinity. And then on my graph, I'm going to go from negative infinity to 5 with a parenthesis there. And 8, I'm having my bracket there. And then shading that. So, oops, kind of didn't go up to my symbols there a little bit. Okay, got the basic idea there. Um, we are, let's see, um, we are done with our lesson for the day. There is one more problem, and I think I will go over that with you tomorrow. Um, and a homework check for 2-7, when do we want that to be? Thursday or Friday? Do you have a preference? Okay. You know, I might just make it Friday because I'm not sure how my life's going to pan out at this point. So 2-7 will be due on Friday, and Friday 11. 11:11. And also, while I have the headphones on, let me say this. Um, I will be emailing all of you about your grade. And if it's C plus or lower, you may choose to have your grade given as pass fail. And then I'll need that information from you hopefully before 8 o'clock tomorrow, except for Kate and Ben, I'm going to give them an incomplete, right? And until I get back and correct your tests, okay? But my grades are due at 8 o'clock tomorrow morning, so anticipate an email from me. And if you happen to see the people who are gone or whatever, maybe tell them to check their email. So